Alright, ladies and gents, so now we're going to compute the moment of inertia about its centroid of the object. Now we computed the centroid, which was 6.18 in the x and 2.13 in the y direction. Now this was done in a previous video. If you want to go back and look at that, or if you've already done that and computed it, fantastic. Now this is also the last video I create for the semester, so we are here. We are almost done. So as I said earlier in the previous video, we already know that this is 1, this is 2, and this is 3. And remember, we cut it here and here for our segments. So our segment, our area, and this is if we're calculating, I should say that, calculating the moment of inertia about the x centroid, or if you wanted to, a lot of books or a lot of things will say x prime and y prime. That's kind of what they'll go by and say. So you're doing it about the x prime axis or the centroid. So again, the area is going to be in inches squared. Our dy, the centroid, in inches. Our ix prime, inches to the fourth. A dy squared, inches to the fourth. And then we have our moment of inertia about its centroid. I'm also going to go ahead and set up my IY. Might as well do it right away so we can just fill in everything. So again, our segment, our area, and just to save time, I'm not going to put the units, but we know what the units are based on up here. And ADX squared, centroid, and IY centroid. Now everything will be the same. Everything will be the same as the previous video. So we had our segments. We're just going to fill them all out at the same time. We have our areas. That did not change as well. It's 10, 7, 2, 10, 7. And Ix prime does not change either. So I'll write down that equation. Remember, Ix prime in this case was 1/12 base times height cubed, and my Iy is 1/12 base cubed times the height. So our Iy prime is 0.167, 83.3, and 0.583. Now, this is what changes on these problems, and of course then it's going to change my ADY squared and ADX squared. So let's take a look at that. We're finding the distance in the y. Alright, so when we're doing this, now we're going about the centroid. So if I'm looking at this spot right here in segment 1, and I draw a line here, this is the distance that I'm looking for. And so if I go up 2.13, now you know this drawing is bad, 2.13, and I go, and I'm only going up to 2, let's draw that in, I'm going up to 2, well, what's left? Well, 0.13. 0.13. Now, for the same thing for the distance of segment 2, that spot's, let's do a different color, because this is going to get messy. Right here, well, I know that this distance from here to here is 0.5, so the rest of it's going to be 2.13 minus 0.5, which is going to give me 0.833. I'm sorry, give me 1.63. 1.63, and that's 2.13 minus 0.5, and then the one up here was 2.13 minus 2. Now the last one here, let's do that one in red. and it's going to be the centroid is right here. So this is the distance that I'm looking for. So again, I went up 4.5 minus 2.13. So I'm going 4.5 minus 2.13, which is going to give me 2.37. Now let's do the same thing for our y's, or for our x's, I'm sorry. And that's going to be this distance, if I'm going from here again, this distance from here to here. Now I know I went 0.5, but now I go all the way to 6.18. So that's going to be 6.18 minus 0.5, which is going to give me that distance of 5.68. Now 6.18, now we know that to get to this point right here, we'll go green again, to this point right here, we go 0.5, I'm sorry, 5 inches, and then from here to here is the remaining piece. So 6.13 minus 5, or is that 6.18? I'm sorry, 6.18. 6.18 minus 5 is going to give me 1.18. And then the last one of this last segment, we're going to be finding this distance right here. So I know I went all the way to 9.5 minus 6.18. Now some of you might be saying, well, you know, you're subtracting one, you should be subtracting this one. It doesn't really matter at this point. It's just a distance, because in the end we're going to be squaring it anyways. So it's going to be the absolute. So after I've done this, this comes out to be the same formula, same punching in the calculator. So we're going to put these in, and I got 0.338. I got 26.57. 39.3, and then down here I got 64.52, 13.92, and 77.16. So I'm just going to fill these in now. I'm just adding these up together, which I get 0.7, 27.4, 67.9, which gives me a grand total of 96 inches to the fourth for the moment of inertia about the centroid in the x or the x prime axis. So then I got 64.7 here, I got 97.2 here, and 77.7 there. Add those up for a grand total of 239.7 inches to the fourth, and that's my y of the centroid. Now the previous problem, when we went about the y and x axis, I got, this was 182.3, and this one is 966. So think about this. Think about why these are so different. Now it's the distances that change, right? Here we're going all the way here and all the way here, but now if we're going from the y-axis, right, we're going all the way across to get that distance. But now, since we're going this around the centroid, it's a lot shorter distance, so we're going to get a lot smaller moment of inertia about the centroid rather than about the x-axis. Alright, well that's it. Under 10-minute video, last video of the semester, unless we need to cover something else. So it's been great. I wish it was all face-to-face the rest of the semester, but it didn't happen. But hope this video helps, and let me know if there's anything else I can help with. Adios.